All right, we're on page 3 of notes 26 for Calc AB, and we're doing integration by parts. This is like a post-AP exam type thing, unless you're in BC, where it's very much a before the AP exam thing. And if you're in Calc 1 or 2 in college, I don't know when you're doing it, but get good at it. So let's see if we can do this one. Evaluate the integral of x cubed e to the x dx. Be really careful with parentheses, so that's kind of interesting. All right, so I see something that if I kept taking derivatives of, it would eventually go to 0, and that's usually a good thing. So I'm going to start with u is equal to that polynomial there, or that power function, really. So u is equal to x cubed, and then dv is everything else. So e to the x dx. All right. So du is going to be 3x squared, and v is going to be e to the x. Oh, I forgot a dx. I forget that a lot. All right, so the integral of, what am I even writing there? Of x cubed e to the x dx is going to be u times v, so x cubed e to the x, minus the integral of v du, which is 3x squared e to the x dx. I recommend that you leave that 3 inside there for reasons that you're going to see in a second. So now you look at this thing and you think like, all right, so to finish this off, I just have to do this integral. But like, how do you do this integral, right? So this integral looks almost exactly the same as the original integral, which probably means we need to use integration by parts. And we do. So that's what we're going to do. Now, when you run into this scenario, make sure you're consistent with your u's and your dv's. Don't like swap them up. Don't suddenly try to make u equal e to the x here on the second iteration. That way leads to kind of like 0 equals 0 almost all the time. Like if you don't make a mistake, you get an identity, but it's not useful because it is not the antiderivative. So I'm going to make u equal 3x squared and dv equal e to the x. I'm going to change colors. So u is 3x squared, dv is e to the x dx. So du is 6x dx, and v is e to the x. Okay, so what are we up to? How many times do I want to recopy this? Like, not that many. You know what I can do? I can use the magic of software here. Okay, so we're at this stage, and now we have minus. All right, so I'm gonna do parentheses here. Nope, I'm gonna do parentheses. Okay, uv, so 3x squared e to the x, minus the integral of v du, so 6x e to the x dx. So 6x e to the x dx. Okay, and let's close that parenthesis. Okay, so I look at this and I'm like, I'm done as long as I can do that integral. But what's wrong with that integral? That's another integration by parts. So I'm going to switch colors again. I'm going to make u equal 6x and dv be e to the x dx. So u is equal to 6x and dv is e to the x dx. So du is going to be 6 and v, 6 dx. Sorry, everybody. And v is e to the x. Okay. So now what can I do? So I'm gonna do my copy and paste again. So we're here, and I wish you could see that part so it didn't seem like so awkward while I'm slowly but surely doing seemingly nothing. Okay, so parentheses. So we're on like whatever, purple parentheses, I guess. So it's uv, so 6x e to the x, 6x e to the x minus the integral of v du. So that's 6 e to the x dx. Finally, I get something I can just integrate. So close that. And then what's our final answer going to look like here? So, all right, so equals x cubed e to the x minus 3x squared e to the x. And then, so then it's, we got 2 minuses now, right? Like this minus, oh, wow, way too big. Hold on. we have this minus sign and this minus sign. So it's minus negative, so that's going to be plus. So we're at plus, and I guess I'll use this color, plus 6x e to the x. And now there's actually 3 minus signs this time because there's minus, that's not a highlighter. It's minus, minus, minus. So 3 minus signs. So that's negative overall. And it's going to be, I guess, the same color. Kind of bothers me that it's the same color. But so it's minus 6 e to the x plus c. Okay. So this, by the way, this definitely factors. Like you take e to the x out, e to the x, and we'll have x cubed minus 3x squared plus 6x minus 6. I like the way that it alternates. That makes me feel like I probably did it right. So we're saying if we took the derivative of this thing, we would get back to x cubed e to the x. Seems insane. Let's find the antiderivative, mostly because I just like don't want to type in that whole thing to find the derivative. I'll do it if I need to, but I'd rather do the integral of x cubed e to the x. You should use the template. It's faster to type exp for me. So we get x cubed minus 3x squared plus 6x minus 6, and then times e to the x. Okay, so this is called repeated integration by parts because you had to use it more than once. This is not uncommon. It's especially common when you have a higher than first degree higher than first degree polynomial as one of your choices, as u basically. You kind of end up doing a lot. So we have to be very careful when we were doing this because of the minus in front of the integral sign, which then like propagates through everything. You're going to be okay as long as you use a lot of parentheses. But there's another way to do this. Did you notice that there's kind of like a pattern here? Like if we look, what would be a good color? So if we look, we had u, and then we had our next u, and then our next u. And then if we did it one more, like if I took another derivative here, I would have had, what color should I use? I would have had another u was 6, and then a du would be 0. And then on this other side, I would have had another dv is e to the x dx, and another v is e to the x. So I'm doing that just so I could get this, right? So look at this column. So we have x cubed, 3x squared, 6x, 6. Now look over here where we have x cubed and then minus 3x squared plus 6x minus 6. It's almost like the answer was just kind of like sitting there, but we need to be clever about the way we organize this. And we can. There's a method. It's called either the table method or rapid repeated integration by parts, which is what I like to call it because that sounds very cool. And so let's actually do that, and we'll see how it works. So here we go. U is going to be x cubed. Now the key thing here is I'm picking dv as e to the x dx. When I make my table, I make my table a little different from how most people make it, especially who's like the stand and deliver guy, Jaime Escalante. He has like diagonals. I go straight across, but we shall see. So here's u, here's v, not v, not dv, and then here we're gonna put the sign. Okay, so I'm gonna start with x cubed, and then you go derivatives down here. So derivatives, we're gonna take derivatives, 3x squared, 6x, 6, and then 0. So if the derivatives of u go to 0 eventually, this method is guaranteed going to work for you. And then here we're putting v. So the first thing we're going to put is v, not dv. So this is e to the x. And then we're going to integrate. So we have to integrate. I can't make a G. What's wrong? Integrate. So we're going to integrate. So you keep going up, but in this case, it's always e to the x, e to the x, e to the x, e to the x, e to the x. All right, the sign. So in the first row, basically what you're doing is uv, and then it's minus, and then the integral, right? So this will be minus, and then the next time it's like minus, and then look at our work, right? We had it was minus, and then I wish there was like a pointer on this, which there's definitely not. We had minus this, right? So I keep choosing that color like every chance I get. We had minus this, right? So that's going to be minus 3x squared e to the x. And then it was minus, but it's two minus signs, right? There's this minus sign and this minus sign. So it became plus. So this will be plus. And then the next time there were three minus signs, and then there were four minus signs, and then there are five minus signs, although you don't really need this one. So now what you're going to do is you go across. So you're going to multiply, let's go bigger. So we multiply across. So it's x cubed e to the x. Then you just write down the sign. So the signs are the things between the terms. So then we put this, so it's minus, and then we're going to go across again. What color was that? It was like a pretty good color. So we go across, but that's a pen. Grr. Okay. We go across again. So we're going to have too many colors. Here we go. 3x squared e to the x. And then we're going to just put the sign. So that's plus. And then we're going to go, I think I've mastered this. Probably spoke too soon. So plus multiply across 6x e to the x. And then we're going to put the sign, which is minus. And then we're going to go across this way. And then we're going to write 6 e to the x. And then you could write plus, but then it's 0 times e to the x. So it's just done. So at this point, we put plus c. So it's a u column, a v column, and a sign column. You multiply u and v, and then the sign just goes between terms. So usually it's going to alternate, but it doesn't need to, because like our v column could sometimes be positive, sometimes be negative. It like messes it up as you go. We're going to do examples later in life where you see some things like that, but this is rapid repeated integration by parts. It is your go-to method, in particular when the derivatives, so when this happens, when the derivatives of u go to 0, this is a great strategy to use. So I'm going to stop this video here. I'll come back. I'll probably do a short video where I just do the last problem on the page, unless the last problem is really hard, like who knows. But I will see you in that video, and then we'll keep going. So hope you're finding these helpful.